Assalamualaikum and good morning. So today our team will be presenting the second assignment for the massive data mining subject. So our project title is Analyzing Social Media Sentiment on Trump's Economic Policies with Machine Learning. This project understanding on how publics react to the economic decision made by the political leader, specifically Donald Trump, through the data collected from social media platforms. So let me start with introduce our team members first. Start with our team leader, Rizky Syaputra, Jiziwan, Muhammad Aziz, Muhammad Tariq Torki and Muhammad Azlan. So to start, economic policies, especially those made by the influential political leader like Donald Trump, can have a profound impact on both the market and the public sentiments. For example, during his administration, decisions such as tariff, tax reform, and trade negotiation with countries like China generate widespread public discourse. So the platform like X in YouTube serve as digital arenas where people voice their criticism and support in real time. So this online conversation provide valuable insight into how people perceive or react to such policies, which is the foundation of our project. This project had three key objectives. First, to classify the sentiments, whether it's neutral, positive, or negative, expressed on the social media platforms about the Trump's economic policies. And second, to compare the performance of multiple machine learning models in handling the sentiment classification task. And third, to examine how public opinion shifts in response to the major economic policy events.
Assalamu alaikum. Greetings, Doctor. I'm here to talk about methodology review. First of all, our data sources are Twitter and YouTube comments, which are focusing on Trump's economic policies. The techniques we're using for text processing are tokenization, lemmatization, and stop word removal. And lastly, for the vectorization, we're using table frequency inverse frequency. For the machine learning models we're using, first of all, the support vector machine, which provide non-dimensional data naive base for simple probabilistic model and k-nearest neighbors for non-parametric method. And for additional techniques, we're using, for example, data balancing to handle class imbalance and sentiment distribution. For the dataset, we're using this is a merged dataset between YouTube and Twitter, which contains, for example, text, which is the comments, the date of the comment itself, and the platform YouTube or Twitter, which is X, and it has around 197,000 rows. For the flow of the dataset, we have the two datasets following YouTube dataset and application X application dataset, which then we merge them together for the cross-platform dataset. For the research methodology itself, it's divided into four phases, which the first one is problem definition, which is defining the problem itself, then data collection phase, and then data propagation, which in data cleaning, text processing, feature engineering, and lastly is the model training method, which containing the traditional machine learning method. And lastly, for the pre-processing, it starts with cleaning the text and handling missing values in the tables itself, for the null values of empty values, then balancing the sets, then tokenization, vectorization, and lastly for train and split. That's it. Thank you.
Hello, hi doctor. I'm Muhammad Azlan bin Amir Wali, part of member from this group also. Okay, today I'm going to present about model training for this project. Okay, for the model training phase, we selected three different supervised learning models to evaluate their performance in our pre-processed dataset. Okay, which consists of high dimensional ITF IDF features. Okay, First, the first model is support vector machines with an RBF kernel. Okay, we used a regulation parameter of C equals to 2.0, and SPM was chosen because it's known for its effectiveness in handling high dimensional data like TF-IDF vectors used in text classification. Okay, the RBF kernel enables the models to capture a non-linear relationship in the dataset. The second model is um, multinomial name bias, okay, which is a popular choice for text classification also. Okay, this model was selected due to its simplicity, speed, and surprisingly strong performance in many natural language processing tasks. Okay, it's particularly effective and when working with word frequency based features like TF and IDF model. The third, the third one is the last one, which include the k nearest neighbor algorithm with k set to 5. Okay. Although KNN is not typically preferred for high-dimensional sparse dataset due to scalability issue, we use it to baseline model to help us understand how more advanced models like SPM and naive Bayes compare to. Okay. It provides useful context for evaluating the relative strengths of the other models. Okay. Here we can see the result of the evaluation model of SPM, naive Bayes, and KNN. Okay. Here you can see the SPM outperform other models, significantly achieving overall of 91% from accuracy, precision, recall, and F1 score. Okay, and the naive bias also is a medium level. It achieves 0.1779, which means 79% of the accuracy of the dataset, precision, recall, and F1 score. And the KNN model performed very poorly. That it achieved only 48% from the dataset. Okay, compared to all this, we can say that SPM support vector machine is a good model for text classification dataset. Okay, then this SPM model has shown best outcome compared to the other classifiers. Like I said before, okay, it reaching an overall of 91% on the evaluated dataset. Okay, this shows strong performance among all three sentiment categories, which is positive, neutral, and negative. The precision F1 scores and recall for each category were high, which is also 0.91% also, 91%, which indicate that models effectively manage the false positive and false negative dataset. Okay. This outcome shows that SPM is high effective in handling high dimensional feature space typical of textual data. Meanwhile, the net bias classifier shows an accuracy of 79% only compared to SPM model. Okay, this model performed reasonably well for the neutral sentiment classification. Okay, with F1 score of 80%, it shows slightly lower performance in determining between positive and negative sentiments. Okay, this efficiency of net bias make it is applicable for baseline model. Okay, however, the assumption of the feature independence may limit the ability capture complex patterns in sentiment analysis text. Okay, the last model we tested out is the KNN model, the K nearest neighbors model. This one is the poorest performance among the compared to the between to the two models, which is SPM and NFIS. Okay, because it achieved only 49% of the accuracy. Okay, although the model shows high recall for the natural classification, which is 93%, but it performed poorly for the negative and positive classes with the F1 score of 43% only and 39% respectively. Okay, this low performance can be because of dimensionality and sensitivity to the choice of distant metric, which affects Canon abilities to generalize all the text classification functions. Okay, thank you so much.
Now we talk about the sentiment analysis. The sentiment analysis shows the 338.1% express positive sentiments, which indicates the support of policies such as tax cuts, deregulation, or perceived economic growth. Meanwhile, negative sentiment shows 35.3% oppose, highlighting concern over worse national depths of inequality. There were 26.6% of neutral sentiment, which often share factual information without a clear tone. This distribution suggests that while there is a chance for approval in Trump's economic policies, it remains a significant topic for public debate and division on social media platforms. Now we talk about the top named entities for sentiment analysis. The table below shows the top 9 entities for sentiment analysis for positive, negative, and neutral sentiment. The word frequency appears in sentiment analysis discussion are dominated by terms like Trump, China, and US. The word Trump appears most in negative, indicating strong criticisms, while US and China feature prominently across all sentiments, showing their role in trade-related debate. Another tool that we want to do with the sentiment analysis is workload sentiment analysis. We start with the workload negative. The negative workload that examines social media reaction to Trump's economic policies shows more criticism on trade issues. Example words like tariff, China, trade war, economic stress, and also look like cost, jobs, inflation, and political like MAGA, bidang, and Democrat. Strongly negative language such as stupid, problem, and crisis shows a lack of confidence in the effectiveness of these policies. While reference to social media platforms like Twitter and YouTube highlight the increased disagreement online. Machine learning techniques reveal these trends, depicting a story of economic uncertainty, lack of leadership, and a demand for more comprehensive and transparent policy development. Okay, now we talk about the workload with positive. The positive workload that shows social media sentiment regarding Trump's economic policies showcase supportive messages focused on tariff with words such as tariff, China trade, and a sense of economic optimism such as economy, business, dollar, and terms of patriotism like America, USA, country. The words like support, hope, and work indicate the approval of the strategies. The quote highlights the protectionist pride, trust in Trump's leadership, and the confidence of economic advantages of the strategies for American workers and business. Okay, now we talk about the workload with positive. The positive workload that shows social media sentiment regarding Trump's economic policies showcase supportive messages focused on tariff with words such as tariff, China trade, and a sense of economic optimism such as economy, business, dollar, and terms of patriotism like America, USA, country. The words like support, hope, and work indicate the approval of the strategies. The quote highlights the protectionist pride, trust in Trump's leadership, and the confidence of economic advantages of the strategies for American workers and business.
Hello, Professor. We conclusion is we trust three models. First is SVM. Yeah, second is naive and KN model. But best is with SVM is best. For sentiment community, for sentiment analysis, SVS model is the most specific suitable for another large scale social media session data. It effectively captures the expression and shows consistent predictive performance. Yeah, thank you, Professor. It's all of